Okay, I'm audible.
Good evening, sir.
Good evening. So, up to last class, we have finished up to Maxwell's equations, right? We have finished these Maxwell equations. Yes. Did we finish Maxwell's equation in the last class? Hishma, Mansi, Yashika, did we finish Maxwell's equation in the last class? Last Friday? Oh, sorry, last Thursday.
Yes, sir.
It's okay. So see, those who were absent in the last class, we have started electromagnetic waves. Electromagnetic waves are a very small chapter. This is the second and the last lecture of electromagnetic waves. And this second lecture is almost independent of the first lecture. So even if you were absent in the first lecture, you can understand second lecture. So these were four equations of Maxwell's. We have finished this thing. Now, the prediction of electromagnetic wave. From the equations, Maxwell's equations, Maxwell predicted a new type of wave, which he called electromagnetic wave. And the special thing about electromagnetic wave was electromagnetic wave can even travel through vacuum. So the calculations for the derivation of electromagnetic wave is not a part of school syllabus. We are not deriving the equation of electromagnetic wave here. We'll give some simple arguments, and after those arguments, I'll directly write the equation of EM wave. I'm repeating again, we can't derive this equation. But yes, through arguments, you can understand that we can, using Faraday's law and Maxwell's law, we can generate a wave which can even propagate through vacuum. So let's see here. So changing magnetic field will give rise to electric field. That was Faraday's law of electromagnetic induction. This is what we did in Faraday's law. Faraday's law says if magnetic field linked with a system change, then that changing magnetic field will give rise to electric field. Similarly, electric field, if electric field linked with a system is changing, then that changing electric field will give rise to magnetic field. That was Ampere's Maxwell's law. This is what we call Ampere's Ampere Maxwell. So these are those two major laws. If magnetic field change, then due to changing magnetic field, we'll get some electric field. That is Faraday's law. If electric field change, then you will get magnetic field, and that is Ampere's Maxwell's law. So assume you have a system which have a changing electric field. So if the electric field is changing, then that electric field can generate magnetic field. But if that magnetic field is also changing, then that will generate electric field again. That electric field can generate magnetic field again using Ampere's Maxwell's law, and this system can generate a type of wave which does not require any medium for propagation. We know that electric and magnetic fields can travel through vacuum also. So a wave that you obtain by the oscillation of electric and magnetic field is known as electromagnetic wave. And this wave does not require any medium to propagate. It can even travel through vacuum. So this is how Maxwell's predict a new type of wave, which is electromagnetic wave, through these two equations, these two arguments. So the derivation is a very interesting derivation, but it's not a part of school syllabus, so we will not touch that derivation. Now, the question arises, which type of physical system can generate these types of changing electric and magnetic field? So if you have an oscillating or an accelerating charge, if you have a charged particle, you have a proton which is oscillating, or if you have a proton which is accelerating, that accelerating or oscillating charge particle give rise to these types of electric and magnetic field, or you can say it give rise to the type electromagnetic field. Please note it down.
Sir,
Yes.
so that oscillating proton, sir, it give rise to magnetic field or it give rise to wave, EM wave?
It give rise to oscillating electric field, which give rise to oscillating magnetic field, which give rise to electromagnetic wave.
Oh, okay, sir. Got it.
Yeah, is this explanation clear? Miraj, Minashi, Mansi?
Yes, sir.
Yes, sir.
Please tell me once you have written scroll it up.
Yes, sir, done.
1 minute.
So it's a very
The
common one marker
EF
question.
is what?
Sorry,
EF.
electric field. EF stands for electric field. And if anywhere I'm writing MF, that will stands for magnetic field. What topping are you people doing in your school? Akshay? Okay. So before 3 days, what topic you were doing there? Okay. Arpit, you? What topic is you're doing in school?
So we started with chapter 9.
Optics. Okay. So everyone
Yes.
have written up to here. Can I scroll it down?
Yes, sir.
So now let's start with the electromagnetic wave. So before starting electromagnetic wave, I'll give you an introduction of what is wave and how does a wave equation looks like. This is revision of class 11 basically. So that's revision of class. So when let's take an example of a particular wave in a string. Wave in a string. So this is a rigid support. You take a string, you give a jerk to this string, and this type of wave will get generated in this string. This one. You give a jerk, and this wave gets generated in the string. This is the wave. So what's happening here? The molecules of the string are vibrating along y-axis, and the wave is traveling along negative x-axis. So this is an example of mechanical wave, a wave which needs medium to propagate. So how this wave is traveling in a string? This is traveling through the oscillation of particles of the string. So there are two displacements. One is the displacement of wave, which is going along x-axis. Another is the displacement of particles of string, which is going along y-axis. So whenever you study wave equations or wave motion, you came across two types of displacement. If you're talking about mechanical wave, one is the displacement of particles about the mean position. Another is the displacement of wave. So here the particles are oscillating about y-axis and your wave is traveling along x-axis. So these types of wave where the oscillation of particles and the direction of propagation of wave are mutually perpendicular, these types of waves are known as transverse. And in class 11th, you also did that the equation of a standard wave is this A sine kx minus omega t, or you can write omega t minus kx. This was the standard equation of wave, of sound wave, wave in a string. This you did in class 11th. Now, you don't have to study mechanical wave. So there is no oscillation of medium particles. We are studying electromagnetic wave. So in electromagnetic wave, instead of the oscillation of medium particles, this is electric field and magnetic field which is oscillating. Electric field is oscillating around y-axis. Along y-axis, your electric field is oscillating. You can see from these arrows also. Earlier arrow is small, then the size of arrow is increasing, then again it's become small. Then the direction of arrow gets reversed. Right? These arrows basically shows the electric vector. So electric field is oscillating along y-axis. So the size is changing. That means the strength of electric field is not constant. The electric field is changing. Along z-axis, if you see, along this z-axis, magnetic field is oscillating. Magnetic field is oscillating. That means the magnitude of magnetic field is changing, and it's changing along z-axis. Just one second. Yeah, sorry. So I was saying when you have a mechanical wave, a wave in a string, in a wave in a string, the medium particles are oscillating and wave is traveling along x-axis. Particles were oscillating along y-axis and wave is traveling along x-axis. When you talk about electromagnetic wave, then there is no medium. Electromagnetic wave does not require any medium to propagate. So instead of medium particle, this is electric field and magnetic field which is oscillating. Electric field is oscillating along y-axis. Magnetic field is oscillating along z-axis. And the wave is propagating along x-axis. So you can see oscillation and the direction of propagation of wave are mutually perpendicular. We have three things. One is electric field, another is magnetic field, and the third one is the direction of propagation of wave. Electric field oscillates along y-axis. Magnetic fields oscillates along z-axis. And your wave travels along x-axis. So the oscillating electric field is clear from this diagram also. See, if you look at this curve, the sine curve, the electric vectors increases, then it decreases, then it increases in the opposite direction, then it decreases. So electric vectors are changing. Similarly, the magnetic vectors are also changing. You can see here along z-axis, electric magnetic vector small, then the size of the magnetic vectors increases, then you can see the size of the magnetic vectors decreases also. So that means magnetic field is also oscillating, but it's oscillating along z-axis. And this is the direction where your wave is going. Let's take an example of light waves. Your light wave is going along x-axis, but your electric and magnetic field vectors are oscillating along y-axis and z-axis respectively. Now, using the last two Maxwell's equations, this equation number basically 3 and this equation number 4, if you want, you can derive this equation, but the derivation is not a part of student's paper, so don't worry about the derivation. You just have to remember this wave equation directly. So when you solve the last two Maxwell's equations, particularly the Faraday's law and the Ampere's Maxwell's law, you get these two equations. So let's write these equations and then I'll explain each of them. Don't worry about the derivation. Derivation is not a part of syllabus. So the first equation is E is E naught sine it's kx minus omega t. This is the equation of electric field. What is the direction of electric field from this figure? Can anyone tell me the direction of electric field from this wave diagram? In which direction
Positive
electric field is
x-axis.
oscillating?
Outwards.
No, electric field. Positive x-axis is the direction which wave is going. I'm asking about the electric field. What's the direction of electric field here? Ishma?
So why?
Yes, electric field is oscillating along y-axis. So we use a unit vector j cap. The j cap shows that electric field is oscillating along y-axis. And what is the direction of magnetic field? What is
Long
the
Z axis.
Z axis.
long z-axis? You can write this as sine it's kx minus omega t. So which unit vector should I use here? Yeah, along z-axis, which unit vector should I use?
K, K cap.
K cap. I should use k cap. So E naught sine kx minus omega t. It's B naught sine kx minus omega t. So you have electric and magnetic field. They are mutually perpendicular to each other. Now, I also need the direction of propagation of it. So if you look at this equation, this term, if you remember from your AC, this term is known as phase. Both electric and magnetic fields have same phase. The coefficient of this k, which is x, this x will give you the direction of propagation. We'll see what is k, what is omega, we'll discuss these things. But first of all, let's discuss the direction. X is the direction of wave propagation. So x is the direction in which your wave is propagating. So your wave is propagating along x-axis. Similarly, you can check the direction of propagation of wave from either equation, from the equation of electric field or from the equation of magnetic field. Both equations will give you the same. Phase is same in both the equations. So this is the equation of electric field and this is the equation of magnetic. If you remember AC, you have done similar things in AC. In AC, you have equation of current I naught sine omega t. This kx is extra. In EMF, in AC EMF, you have E is equal to E naught sine omega t. Only the kx term is extra. So let's discuss each and every term. What is E naught? Can you relate it with the AC? What was E naught in AC? Which value was this E naught? Instantaneous, RMS, average. Which value was this E naught? Array?
Peak value.
E naught was the peak value. So here also this E naught is peak value of electric field. Similarly, what is B naught? It's the peak value of magnetic field. This X gives the direction of wave propagation. Omega, as you know, omega is the angular frequency. This is also the same quantity that you did in AC. The new term is this K. This K is known as angular wave number. Basically, this K is related with the wavelength of the wave. You can write your K as 2 pi over lambda. The lambda is the wavelength and this K is nothing but your angular wave number. So this K is the angular wave number. So angular frequency omega is 2 pi by t. Then you can take ratio of, okay, this is angular frequency, this is angular wave number, E naught, B naught are the peak value. And what about E NOHA? What is E here? Which value is this E? The RMS value, instantaneous, average, what is this E?
RMS value.
RMS value. Yashika, is this E the RMS value?
Instantaneous.
Instantaneous NOHA. This E depends upon time. This E is the instantaneous value. This is the instantaneous value. Similarly, this B is also the instantaneous value. Okay, there is one more interesting thing. If you take the ratio of E naught and B naught, E naught is the peak value of electric field, B naught is the peak value of magnetic field. If you take their ratio is equal to C, which is speed of light. This is interesting thing. If you take the ratio of peak value of electric field and the peak value of magnetic field, the number comes out to be equal to speed of light. So if you know one, like if you know peak value of electric field, using this relation, you can get the value of peak value of magnetic field and vice versa. So EB, now another thing. You have three things. One is electric field, another is magnetic field, and the another is direction of propagation of wave. So electric field, magnetic field, and direction of wave propagation, they are always mutually perpendicular. Always, always. That's why we say that electromagnetic waves are transverse in nature. So this is an example of transverse wave motion. So electric field, magnetic field, and direction of propagation are mutually perpendicular to each other. Now, when they are mutually perpendicular, they follow right-hand thumb rule. They follow right-hand thumb rule means if you want the direction of propagation of wave, let's say I give you the direction of electric field. I tell you that direction of electric field is along y-axis. The magnetic field is along z-axis. And I ask you to predict the direction of wave propagation. Miraj, can you guess the direction of wave propagation? Electric field is along z-axis, let's say. Magnetic field is along y-axis. What should be the direction of propagation of wave? Miraj,
Long axis.
along x-axis. But now you have two options. What two options does Miraj have, Saifullah?
So can you repeat the question?
I asked Maharaj that if electric field is along z-axis and magnetic field is along y-axis, what is the direction of propagation of wave? Maharaj said it's along x-axis. Now I'm saying that Maharaj have two options for the direction of propagation of wave. What are those two options?
It's the negative x-axis.
So there are two options. Your wave can either propagate along positive x-axis or your wave can go along negative x-axis. But obviously one of them is correct. So the correct one you can get from right-hand thumb rule. So here also you will use right-hand thumb rule, and the right-hand thumb rule says place your fingers along the direction of electric field. So what you can do is just take your right hand, place your fingers towards the ceiling. Electric field is along y-axis in this example, so place it towards the ceiling. Magnetic field is coming out of the plane of your laptop or the notebook. Just curl it outwards. Your thumb should go along positive x-axis. Yes. Are you getting your thumb along positive x-axis?
Yes, sir.
Yes, sir.
So this is the direction of propagation of wave actually. Your wave is traveling along positive x-axis. So place your finger along the electric field, curl it towards the magnetic field. Your thumb will give the direction of propagation of wave. So this is how you can predict the direction of propagation of wave if you know the direction of electric and magnetic. So this is what I have written here, direction. And there is no phase difference between electric and magnetic field. Electric and magnetic fields are exactly in same phase. If you look at the phase, this one and this one, they have the same phase. There is no phase difference. There is one more interesting thing. Like if I write the equation as E naught sine kx minus omega t, which term will give the direction of propagation of wave only? In this equation, E is E naught sine kx minus omega t. Which term will give the direction of propagation of wave?
Sir, kx minus omega.
Sorry?
Kx minus omega.
Not the complete kx minus omega, only the x, right?
Sir, yes, sir.
The coefficient of k will give the direction of propagation of wave. You are having x with k, that means your wave will travel along x-axis. I'm repeating again. Electric field is not along x-axis. The coefficient of k will not give the direction of electric field. It will give the direction of wave. So your wave is going along x-axis. And since you are using a negative sign here, that means your wave is traveling along positive x-axis. Ulta here. It's opposite. Like if you have negative sign, that means the direction of propagation of wave is along positive x-axis. If you had positive sign here, that means your wave will travel along negative x-axis. That is the difference between. And why this negative sign represents the positive x-axis, why this positive sign explains the negative, represent the negative direction of x-axis. This is class level syllabus, so I don't want to go in that detail. That detail will not help you in any numerical here. So I'm not going in that detail now. So this is the electromagnetic wave. So is it clear or you have doubts, discussions? Minashi, Mansi, Hishma, Anshika, Yashika.
Kx minus omega plus kx plus omega की दोनों में x से positive.
पुनीत तुम्हारी आवाज कट रही है यार, मतलब बहुत क्लियर नहीं है, दोबारा बोलना एक बार प्लीज. मुनीब आप कुछ कह रहे थे, मैं सुन नहीं पाया. Okay, so note it down and tell me if you have any doubts or I can discuss. Okay. Okay, Uni. Please note it down. This is the last topic. So let's try to finish this thing in next 30, 25, 30 minutes. Then we'll start modern physics or optics, whatever you say. What topic are you all doing in your school? Are you doing optics or modern physics? Noha. So we'll plan accordingly. Yeah? We can start with optics also, or we can start with modern physics also. Like you are
We are
doing
doing optics in our school.
optics. Optics. What about the rest, Anshika?
So we have started wave optics.
Wave optics. Okay, so everyone is doing optics. So let's start with optics. Let's start optics too. Optics is again about these wave equations. Na? So after EM waves of we can start with wave optics. Optics is the last major unit of your syllabus. After optics, all chapters will take hardly one lecture. Dual nature, one lecture, atom, one lecture, nuclei, one lecture, semiconductors, one lecture.
So we will have a test series after that.
Yes, yes, yes. Let me finish this chapter today. From the next week onwards, we'll have a test series for the first book, entire first book. And also, maybe in a week or two, the notification of JEE mains will come. So those who are interested in JEE mains, just apply for it. The first attempt would be in January. We were expecting first attempt in April, but they're taking in January only. So the first attempt will be in January. Second attempt will be in April.
So this time NEET will be in which month?
May.
May, most probably May. It will be.
The date has come out, sir. It is May only.
May. Basically, the final date is not yet announced, but yes, most probably it will be in May.
Will the test series questions be subjective or objective?
Both. Exactly according to the pattern of your exams. We'll have two test series. One is for your boards exams, and then we'll have one for your NEET and JEE. Tell me once you have written. Scroll it down. Yes, can I scroll it now? If you have written.
1 minute, sir.
Okay, so must have written up to it, huh? Note it down. Any doubt up to here? Anshika, Yashika, Safullah.
Yes, sir.
Haji, can I scroll it now? Yashika, Uneep, can I scroll it now?
Yes.
Okay. I write down these statements also. Noah, what topic are you doing in your school? Same optics or Haji written? Everyone have written up to here?
1 minute, sir.
सर फर्स्ट लाइन में क्या लिखा हुआ है E and
E, B, and direction of propagation are mutually perpendicular and follow right rhythm. Electric field, magnetic field, and direction of propagation. Yes, can I scroll now?
No, sir.
Just tell me once you have written. See, all these are one marker question. The phase difference. This is a one marker question. Is there any phase difference between electric and magnetic field? And you should remember this thing. If there is negative sign, that means a wave is traveling along positive x-axis. If you have positive sign, that means wave is going along negative x-axis. Can I scroll it now? Tafullah, Minashi.
Yes, sir.
Yes,
Okay. So let's start with this question. Huh? Just
सर
note down
एक
this question.
सेकंड इस वाले में दोनों x तो पॉजिटिव है तो फिर
No, this is negative x. This is
अब
positive.
एक सर इक्वेशन में तो kx पॉजिटिव लिखा
No. It's not about kx. It's about the sign between kx and omega t. If the sign between kx and omega t is negative, that means wave is going along positive x-axis. If the sign between kx and omega t is positive, that means your wave is going along negative. This is how.
ओके सर
Written.
Just a second, sir.
Note down this question. It's
Roll up.
20 sine 5x minus j. Okay, let's do this question together. Let's start with Noah. Yes, Noah, am I audible?
yes, sir.
So this is the equation of electric field, Noah. Huh? E is 20 sine 5x minus 10t. We'll do it together. What is the peak value of electric field here?
20.
20
20 Newton per coulomb. What if I ask the RMS value? Suppose if I ask you the RMS value of electric field, how do you calculate it?
E naught upon root 2.
V naught by root 2. Is it clear? See, the relation for ERMS average will remain same. It does not matter whether you are doing AC or you're doing any other thing. RMS is a type of average. So it does not matter what you're doing. So RMS value of electric field we already discussed. RMS value will be E naught by root 2. So E naught is 20 over root 2 Newton per coulomb. Third part. Angular wave number. Minashi, what's the angular wave number here in this equation?
Sir, my 10.
No, 10, yes. See, you can compare it to the standard wave equation. E is E naught sine kx minus omega t j cap. So when you compare with the standard wave equation, you get, instead of k, you get 5. So you can say angular wave number here is 5. Oh, so k is 5. K is 5.
Sir, 10.
No, angular wave number. So angular wave number is this k. Omega is not the wave number. Omega is the angular frequency. I'm asking k, which is 5. radian. Okay, Minashi, it's 5, not the angular wave number, it's not the frequency. Okay, let's talk about the second. Wavelength. Mansi, how will you calculate wavelength of wave using this given data? Is there any term here which is related to wavelength? Fishma?
Angular wave.
Yes. Fishma? How will you
Sir,
calculate
T
wavelength here? Sorry?
is a 2 pi by k.
Yes. K is 2 pi by lambda. So you can say that your lambda will be 2 pi by k. So it's 2 pi by 5 meter is the wave. After wavelength, angular frequency. So, Anshika, how much is the angular frequency here? Anshika, how much is the angular frequency here?
Sir, it is 10.
10. So angular frequency is 10. When you take unit, it's 10 radian per second is the omega. So once you have omega, can you calculate the value of time period? Arpit, you have omega. How do you calculate time period using omega? Arpit. Right, Alia. Mansi, will you try? If you have omega, how to calculate the time period? See,
So differentiation.
no. Omega is 2 pi by t. So you write your t as 2 pi by omega, which implies that your time period is it's 2 pi divided by omega. How much is omega? Omega is 10. So it's pi. Now, if you have time period, can you calculate frequency? Minashi, if you have time period, can you predict frequency?
Angular frequency.
No, angular frequency we know, but it's given. I'm asking about the linear frequency. Can you calculate linear frequency if you have time period?
1 by time.
1 by time period. Frequency is just 1 by time. So if your time period is pi by 5, then frequency is 5 by pi. And the unit is hertz. Is it clear up to here? Now, in the next part, you need equation of magnetic field. So, Yashika, what will be the equation of magnetic field for this system?
B naught sine
Mm-hmm.
omega t plus kx.
Plus kx minus omega t. Na? The phase will remain same. Phase will not change. So, B naught sine 5x minus 10t. And the direction, what should be the direction of magnetic field, Yashika?
So perpendicular to electric field.
So, what is the direction of electric field then?
Z y.
Electric field is along y-axis. So, where should be your magnetic field? Yes, what should be the direction of magnetic field then?
X or Z.
X or Z, but your wave is traveling along x-axis, na? Then which direction is left?
Z.
Z. See, this is for everyone. Electric field, magnetic field, and direction of propagation are mutually perpendicular. So you're using this equation, you can see that electric field is along y-axis, because J cap is given. Along with K, you have X, that means your wave is traveling along x-axis. The only thing which is left is z-axis. Your magnetic field will be along z-axis. I'm using a K cap. But again, this B naught, we don't know how to calculate B naught. Yashika, can you calculate B naught? Do you remember any relation from where you can calculate this value of this B naught?
Sir, E naught by B naught is equal to C.
Yeah, E naught by B naught is equal. So you can write that your B naught is simply E naught divided by C naught. So how much is E naught? E naught is 20 and C is 3 into 10 raised to the power 8. So this much of Tesla is your P naught. You can substitute the value of P naught. So this will be 20 by 3 into 10 raised to the power minus 8 sine 5x minus 10t k cap. Is it clear, everyone? Ishma, Minashi, Anshika, Arpit, Akshay.
Yes, sir.
Yes, sir.
Okay. So let's do one more thing. Just one last thing is this. Uh, what next we can calculate? We can just quickly calculate the direction of wave propagation. So Akshay, what is the direction of propagation of wave? Arpit, what is the direction? No, not Arpit. Akshay. Akshay, what is the direction of wave propagation? Using this equation of electric. Positive x, negative x?
Positive.
Positive x, right? Because along with k, you have x. Along with 5, you have x. That means wave is traveling along x-axis. Now here you have negative sign. That means it's positive x. Okay, just note it down. Tell me if you have doubt in any part. Doubts? Anshika, Alia, Hishma. Can I scroll it if all of you have written? Yashika, Noah.
Yes, sir.
Okay. Okay. Now the last section of this chapter is the properties of electromagnetic wave. We have certain properties of electromagnetic wave. Everyone are written? Miraj, Anshika, Akshay.
Yes, sir.
Okay, let's do a tricky question from here. Huh? This was straight formula based thing. Let's do a tricky question. So let's. You just have to decide the direction. Huh? So let's say, for example, this is the equation of electric field. Some E is E naught, sine some K, some K, some M cap minus omega t into some A cap. I don't know the exact direction. See, it's not necessary that waves are traveling either along X, Y, or Z. They can travel in any direction. So electric field is along A cap. Your magnetic field is along B naught sine. It's K M cap minus omega T B cap. This is the direction of electric field. This is the direction of magnetic field. Predict the direction of EM wave. Yes. Can anyone predict the direction of EM wave in terms of A cap and B cap? Akshay, Alia, Anshika.
A cross B.
Very good. See, the EM wave is perpendicular to both vector A as well as vector B. So the direction of EM wave is A cap cross B cap. This will be the direction, not just A cap cross B cap, but you have to divide by A cap cross B cap magnitude also. This is the unit vector M cap. See, why I take the cross product? It's because when you take cross product, the result of the cross product is perpendicular to the either vectors. So this A M cap is perpendicular to A cap as well as B cap. Please note it down. This is how you can decide the direction. Okay, let's do some properties of EMF. The first property. Electromagnetic wave is transverse in nature. Transverse means the thing that we have just discussed, that electric field, magnetic field, and direction of propagation, they all are mutually perpendicular. That's the first property. Second property, E naught, the ratio of E naught by B naught is equal to speed of light. Third, an interesting property is if you take 1 by root over mu naught epsilon, that is equal to the speed of light. What is mu naught here, Anshika? What does mu naught represents here?
Sir, the permeability.
Permeability, and epsilon naught is the permittivity. If you take this ratio, mu naught is 4 pi into 10 raised power minus 7. Epsilon naught is 8.85 into 10 raised minus 12. When you do this calculation, it's 3 into 10 raised power 8 meter per second. This expression is very important for the questions on dimensional analysis. If you look at the previous year's questions on NEET and J, you will find many questions on dimensional analysis where he asked the dimensions of 1 by root over mu naught and epsilon naught. 1 by root over mu naught epsilon naught is speed of light. So its dimensions is equal to that of speed, which is L1t minus 1. Next property. Okay, this is when you take mu naught and epsilon naught, that means you are in vacuum. But when you go to medium, what changes you expect in this expression? Saifullah? If I go to some medium, what changes would you expect in this expression?
There will be mu into epsilon.
Mu into epsilon, yes. So this will be mu into epsilon. What is mu? It's mu r into mu naught, relative permeability into mu naught. Epsilon is epsilon r into epsilon naught. So what you can do is 1 by root over mu r epsilon naught. You can keep it side aside. Then you have 1 by root over mu naught epsilon naught. What is 1 by root over mu naught epsilon naught? That's c. So we c by root over mu r epsilon naught, where c is the speed of light. And this is relative permeability and relative permittivity. And this mu r epsilon r is nothing but the refractive index. So the refractive index that you studied in ray optics, which is the ratio of speed of light in vacuum to the speed of light in medium, that can also be written as in this way, root over mu r into epsilon r. So this is how we calculate the value of refractive index. If you know permeability of medium and you know the permeability of free space, relative permeability, then you can get the value of refractive. Next, all optical phenomena. When we talk about optical phenomena, means reflection, refraction, interference, diffraction, polarization. All optical phenomena are due to electric field only. There is no role of magnetic field in optical phenomena. Okay, note it down up to here, then we will calculate the energy. Energy is the last topic. Miraj, Arpit, Vishma, any doubt?
No, sir.
No, sir.
Alia, any doubt? Arpit,
No, sir.
So what is V?
V is this one, this V,
Yes, sir.
speed of light in medium. C is the speed of light in vacuum. V is the speed of light in. Yes, can I scroll? Uneeb, Noha, written up to here, 0.6.
No, sir.
Once.
Tell me once you have written. Yes, can I scroll now? Jasola, you written now?
Yes, sir, done.
The next is the energy. Okay, this is important. So the last topic in EM wave is energy. See, electromagnetic waves have energy. The example of electromagnetic wave is light wave, X-rays, cosmic waves, gamma waves, and all these waves have energy. So now we'll discuss from where that energy comes. So let me just energy in electromagnetic. The electromagnetic wave is nothing but the combination of electric and magnetic field. So the energy of EM waves comes partially from electric field and partially from magnetic. Or you can say 50% of energy of EM waves comes from electric field and the rest 50% comes from magnetic. And those energy you have already discussed. The electric energy density you have done in capacitor and magnetic energy density you have done in inductor. So energy density in EM wave. Energy density EM. Ishma, what do you mean understand by this term energy density? What does energy density means?
Energy by volume.
Energy by volume, energy per unit volume. So let's first discuss electric energy density. Electric energy density. See, we can represent electric energy density by UE, and this is half epsilon naught into E square. See, this E is basically the RMS value. Since electric field is changing, so this is the RMS value of electric field. This is the RMS value of electric field. RMS value of electric. Next, you can, if you want, you can convert it in terms of peak value also. Anshika, what is the relation between RMS value and peak value? Can you convert ERMS in terms of E naught?
Sir, ERMS is equals to E naught by under root 2.
Yes, ERMS is E naught by root 2 then whole square. So you can write this as it's half epsilon naught. It's E naught square divided. Or you can say this is 1 by 4 epsilon naught E naught square. This is electric energy. Similarly, you can also calculate magnetic energy density. Does anyone remember the formula for magnetic energy density in an inductor? So these are two relations for electric energy density. You can either write in terms of ERMS or you can write in terms of peak value of electric. Magnetic energy. Magnetic energy. We represent magnetic energy density by UB. And magnetic energy density is half B square divided by mu naught. We did this in chapter number 6, electromagnetic waves, electromagnetic induction in inductor. And if you want, you can convert in terms of peak value also. So that is 1 by 2 mu naught. B RMS you can write as B naught by root 2 whole square. So it comes out to be, it's 1 by 4 B naught square divided by mu naught. So this is the magnetic energy density. Either this or this. This is the magnetic energy. After magnetic energy density, we have, and there is one more interesting thing, that electric energy density is exactly equal to magnetic energy density. Both the energy densities are exactly equal. So if you take electromagnetic wave, as I said, 50% of contribution will come from electric field and the rest 50% will come from magnet. Next, what you can do is you can calculate total energy. Total energy. So the total energy density is the sum of electric energy density and magnetic energy. Or if you know that electric and magnetic energy densities are equal, so you can write this as it's either twice of electric energy density or this is twice of magnetic energy. So this is electric energy density. If I take twice of this will be 1 by 2 epsilon naught E naught square. 1 by 2 epsilon naught E naught square. If you take twice of magnetic energy density, it's 1 by 2 P naught square divided by. This is the total energy. Either this or this. Both are equal. Now, instead of energy density, what if he asks you to calculate the total energy? Let's say he asks you to calculate total energy. See, energy density is energy per unit volume. So total energy will be its energy density multiplied by the given volume. So this is energy density multiplied by volume. If volume is given and you can multiply your volume with energy density, you will get total energy. So you can write this as small u multiplied by the volume. Small u is the energy density and P is the volume. Note it down. So this is the source of energy of electromagnetic wave. Partially it comes from electric field and the rest comes from magnetic. Doubts? Miraj? Arpit? Akshay? Akshay, any doubt here?
No, sir.
Market capacity. Yes, written up to here.
Yes, sir.
Okay. So that was the energy, total energy. Next, basically there are few more topics which are not in NCRT, but you should know those topics. There is one numerical in NCRT which will use that topic. So we'll do that in the next class. Or we have still time now, we can do it in the next 10 minutes. This is the total energy density. After total energy density, there are three terms. One is the power and another is the intensity. These power, intensity, these discussions are very generic discussions. Like they are not just limited to EM wave. The same discussion can be extended to kinetic theory of gas. This can be extended to dual nature of matter and radiation. This can be extended to thermal properties, basically radiation stuff that was in class 11 syllabus. So one is power. Power is nothing but energy by time. So the power carried by wave is the energy divided by time. So if you represent power by P and you represent total energy by U, then power is U by T. So your SI unit of power is watt. Another is intensity. Intensity is basically power divided by area. Intensity is energy per unit area per unit time. So it's basically power divided by area. It's energy by area by time. Intensity of EM wave is energy density multiplied by the speed of light. Is the total energy density. Total energy density. No need to do the derivation of this thing. I have derived it, but it's no need of it. So these are the two terms that one can use while solving some questions of NCERT. But these discussions are very generic. Power is just energy by time. Intensity is energy per unit area per unit time. Particularly for EM wave, you can write your intensity as energy density multiplied by the speed of light. Speed of light. You may use this relation in some objective questions. Please just note it down. Just note down this point number 9 and point number 10. By the way, what should be the SI unit of intensity? SI unit. See, it's power divided by area. Power is watt. So it will be watt per meter square. This is intensity. Watt per meter square. Power by area. Is it written up to here? Is power and intensity? Arpit, Miraj. Uneeb.
Yes, sir, right.
Yes.
Okay. After this, there is last expression, which is momentum. Electromagnetic waves also carry momentum, and the momentum is total energy divided by speed of light. Note this one also. This is the momentum carried by EM wave, which is total energy divided by the speed of light. Please note it down. The question on this relation is not in EM waves, but in dual nature of matter and radiation, chapter number 11. Note it down. The momentum is total energy divided by speed of light. I'm not deriving these results. These are generic results. So no one is going to ask you the derivation in your exam. So you have written up to here, Ishma? Inashi?
Yes, sir.
Saifullah? Okay.
Yes, sir.
1 minute, sir.
Total energy divided by speed of light is the momentum. Yes, Saifullah. Can I scroll it now?
Yes, sir.
After this, the last and the most important thing is this electromagnetic wave spectrum. So see, electromagnetic waves range from gamma rays to radio rays. So gamma, X-ray, ultraviolet, visible, all are examples of electromagnetic wave. So there is a type of question, a theoretical question. In those questions, they ask about the frequency range, like gamma rays exist from 10 raised power 22 to here 10 raised power 29. What is the frequency range of gamma rays? What is the wavelength range of gamma rays? What is the frequency range of visible light? What are the uses of visible light? What is the mode of production? So these are the questions that one can ask from electromagnetic spectrum. See, I can't help you in this spectrum because you just have to memorize everything. You have to memorize the frequency range and the wavelength range of each wave. And then you have to memorize the mode of production and also the uses, how you make those waves. The uses, mode of production, frequency, and wavelength range. And by the way, this is the most important question in EM wave. If you look at past year questions of boards, they are very, if you look at the 10 years question, only in 10-20% cases, they asked all those topics that we have studied till now. In majority of cases, they ask this electromagnetic spectrum. It's very, very, very important. So you just have to memorize the frequency range, the wavelength range, the mode of production, and the user. Like if I can remember, there was one question, there is a wave which is used in detection of defects in bone. So that is X-rays. Then you have to write the wavelength and the frequency range of X-rays. Then how would you produce X-rays? X-rays. So this is electromagnetic spectrum. With this, this is over. Electromagnetic wave is over. The next class, we'll start optics. We'll start with wave optics, most probably. So if you have doubts, we can discuss. Otherwise, I will leave.